Imagine standing in the middle of the Sahara. No forests, no rivers, no endless green fields, just sand stretching toward the horizon. Now imagine watching a river appear in the middle of that desert. Not a natural river, not a miracle, but a massive engineered water system carrying millions of cubic meters of water toward land that, for thousands of years, was considered too dry for large-scale agriculture. And then something even more unbelievable happens. The desert starts turning green. Egypt is attempting exactly this with one of the most ambitious agricultural engineering projects on Earth, the New Delta. The goal? To transform around 2.2 million fettans of desert, roughly 9,000 square kilometers, into productive agricultural land. That's an area larger than many major cities. But here's the question that makes this project so fascinating. Where is all the water coming from? Because Egypt isn't simply finding a new river. It's building an enormous system to collect, treat, pump, transport and distribute water across the desert. And the engineering challenge is staggering. So today, we're going inside Egypt's attempt to create a new agricultural frontier, and uncover how you can move water across a desert where gravity itself seems to be working against you. The country that has almost no land to farm. Egypt looks huge on a map, but most of that land is practically empty. The overwhelming majority of Egypt's population and agriculture are concentrated around the Nile Valley and Nile Delta. And that creates a problem. Population grows, cities expand, demand for food rises, but the amount of naturally fertile land doesn't magically increase. So Egypt has been pursuing a radical strategy: take the desert, and make it productive. The New Delta is part of that larger strategy. According to Egyptian authorities, the project targets about 2.2 million fettans for agricultural development. NASA has also documented the transformation of large desert areas west of the Nile Delta into agricultural land. But there is a fundamental obstacle. And it's not the sand, it's water. You can have unlimited sunlight. You can have enormous amounts of empty land. You can build roads, farms and factories. But without reliable water, the desert stays desert. And that is where the real engineering story begins. The river, that isn't really a river. When you see videos online describing Egypt's project as a 310-kilometer artificial river, it sounds like Egypt literally dug a giant natural-looking river through the Sahara. That's not quite what is happening. The New Delta system is better understood as a huge network of water routes, canals, pipelines, treatment facilities and pumping stations. At the 2026 inauguration, Egypt's presidency described two major lined routes, the northern route and eastern route, each about 150 kilometers long. Together, that's approximately 300 kilometers of major water routes. And then there are hundreds of kilometers of associated channels and distribution infrastructure. So why call it an artificial river? Because at its heart, that's what the system is doing. It is creating a controlled flow of water where nature doesn't provide one. Except this isn't water simply flowing downhill. Some of it has to be moved against the natural slope of the land. And that changes everything. The water comes from somewhere you wouldn't expect. Here's one of the most surprising parts of the story. The project isn't relying only on fresh Nile water. Egypt is also trying to reuse something that was previously treated as waste: agricultural drainage water. Think about what happens after farmers irrigate fields. Some water eventually drains away. Historically, large quantities of drainage water could ultimately reach the Mediterranean. Egypt's strategy is, why throw that water away, when it can potentially be captured, treated, and used again? This is where advanced water treatment becomes critical. According to Egypt's irrigation ministry, the northern source for the New Delta supplies around 7.5 million cubic meters of treated agricultural drainage water per day using advanced tertiary treatment. 7.5 million cubic meters every day. That is not a small irrigation canal. That's an industrial-scale water recycling system. The water is collected. It is transported, it is treated, it is pumped, and then it enters the agricultural system. In other words, Egypt isn't just trying to create more farmland, it's trying to create more useful water from water that has already been used. Now we reach the engineering challenge that makes this project truly fascinating. Water naturally follows gravity. Give it a slope, and it wants to move downhill. But the New Delta's infrastructure has to move water across terrain where the natural elevation isn't enough to carry it where engineers need it to go. So Egypt built enormous pumping infrastructure. The presidency says the system uses 19 major pumping stations to move water toward the agricultural areas. And these aren't ordinary water pumps. These are pieces of infrastructure designed to move millions of cubic meters of water every day. Egypt's irrigation minister reported that one of the routes includes 6 major pumping stations, with internal stations distributing water through the agricultural areas. Some individual stations contain more than a dozen pumps and can lift more than 9 million cubic meters of water per day. Think about what that means. Every minute, water is being lifted, pushed and redirected. The system essentially creates an artificial hydraulic landscape. Instead of allowing geography to decide where the water goes, engineering decides. But pumping water isn't enough. You can't simply flood the Sahara and expect a farm to appear. The soil has to be prepared, the water has to be controlled, and irrigation has to be extremely efficient. That's why the new Delta project uses modern agricultural infrastructure and irrigation systems. The objective isn't simply to grow a few crops. It's to create an enormous agricultural production zone. The Egyptian government says the project is designed to support crops including wheat, corn, sugar beet and other strategic agricultural products. And here's where the desert becomes surprisingly valuable. Certain crops can perform differently in desert soils compared with the older agricultural lands of the Nile Valley. Egypt's president has described a strategy where traditional crops such as wheat and corn can remain concentrated in the highly productive soils of the Old Valley and Delta, while some new desert lands can specialize in crops such as sugar beet. The goal is simple: get more food from every piece of land and every unit of water. That's not just agriculture, that's optimization. Let's step back for a second, because numbers this large can become meaningless. 2.2 million fedans, 9,000 square kilometers, hundreds of kilometers of water infrastructure, 19 major pumping stations, thousands of pieces of agricultural equipment, thousands of kilometers of roads and supporting infrastructure. This is no longer just a farm, it's an entire new agricultural landscape. Egyptian officials estimate the wider project will involve investment on the order of 800 billion Egyptian pounds, while the project is also intended to support major employment and economic activity. And that's an important distinction. The objective isn't only to produce vegetables or wheat. The idea is to build an interconnected economic zone: farm, road, power, water, processing, storage, transportation, and eventually, communities. The desert isn't empty, it's being re-engineered.